Hi kids, Mr. Josephs here. I'm going to read you the beginning of this ions handout and give you a little more commentary about it so you understand ions a little better. So let's get started. So ions. How often do you go to use your phone or your Chromebook just to find out that it's dead? I bet you find your Chromebook is dead more often in Mr. Joseph's class. You probably know that your phone is powered by a battery. More specifically, the battery is a lithium-ion battery. Lithium-ion batteries are extremely common these days from not only mobile phones, but also to electric cars and all sorts of electric devices in between. Lithium-ion batteries are used because they can hold a lot of energy for a relatively low weight. See the energy contained in a lithium-ion battery by using the QR code to the right and viewing a short video. Trust me, this video is pretty cool, so you want to go watch it real quick. It's only 1 minute long. So, we use lithium-ion batteries all the time, but what exactly is an ion? An ion is a charged particle that forms from a neutral atom. As you have already learned, atoms are neutral because they contain equal numbers of protons and electrons. The positive charges possessed by the protons balances the negative charges possessed by the electrons. In the process of forming an ion, at least one electron is either lost or gained by an atom. This leaves an overall charge imbalance between protons and electrons. If an electron is lost from a neutral atom, more protons exist in the nucleus than do electrons in the surrounding electron cloud. The newly formed ion, it is no longer called an atom since it has lost an electron. It possesses a positive charge. Below is an illustrated example of the formation of a lithium ion from a lithium atom. As can be seen in the illustration above, an atom of lithium contains 3 protons in the nucleus. This particular atom also happens to have 4 neutrons, which matters not a bit in this discussion of ions. The lithium atom also contains 3 electrons, which balances the charges of the protons, resulting in a neutral charge for the atom overall. So let's take a look at an example. So here is the lithium atom. We have, actually in our example on the handout, they had 4 neutrons. Doesn't matter though. So you can see that there's 3 protons and 3 electrons, and the net charge is 0. You're going to be using this applet later on too. On the other hand, the lithium ion, while also containing 3 protons, only contains 2 electrons. 2 electrons are not enough to completely balance the charge of the 3 protons. This means that the overall charge on the lithium ion will be positive. Protons possessing positive charge and being more numerous than the electrons, which possess negative charge. Because the difference between the number of protons is greater than the number of electrons by 1, the specific charge, known as net charge, on the ion is +1. And let's take a look at that. So you can see if I take this electron away, now you can see that the net charge is +1 on that ion. Now the lithium ion example shows how an atom transforms into an ion when it loses an electron. But what happens when an atom gains an electron? What happens when an atom gains or loses more than 1 electron? Let's examine another example to answer these questions. Let's start with an oxygen atom, and see what happens when it gains 2 electrons. See the illustration on this next page. So in this case, because the neutral oxygen atom gained 2 negative subatomic particles, these electrons, the resulting ion is negatively charged. The oxygen ion, like the oxygen atom, has 8 protons in its nucleus. The electrons, orbitals surrounding the nucleus, contains a total of 10 electrons. Because the number of protons is less than the number of electrons by 2, the total charge or net charge on the oxygen ion is -2. Here is an oxygen atom, and so they have the same number of electrons and protons, so their charges balance out to a net charge of 0. But if we add 2 electrons, then we see that there are 2 extra negative things than there are positive things, and so the net charge now becomes -2. From these two examples of ion formation, we can draw several general understandings. Firstly, that if the number of protons in an ion is greater than the number of electrons, then the charge on an ion will be positive. If the number of protons is less than the number of electrons, then the charge will be negative. Secondly, the net charge of an ion is equal to the difference between the number of protons and the number of electrons contained within the ion. Now we're going to go down and you'll watch this video by yourself, but I want to show you the first two rows of this table on question number 11 and how to do this. Okay, and we're going to use this PhET atom builder. And so I'm going to go to the builder, which we have already looked at a little bit. Okay, I'm going to make this the lithium atom. Okay, all right, so we're going to look at this lithium ion. Now, all lithium atoms and lithium ions must have 3 protons in it because that is what lithium has. If you change the number of protons, then you would change what type of element or ion you have. So lithium must have 3 protons. So let's add that to this here. 3. Now, because our number of protons is greater than our number of electrons, our positive particles is greater than our negative particles, that means that we have a positive ion. Okay? What's the difference between the number of positive particles and the number of negative particles? Well, the difference is only 1. So the net charge is plus 1. And so our ion notation, we're going to use the symbol for lithium, Li, and we're going to just put a plus. We don't have to put a plus 1 for when it's 1, we can just do plus. Okay, let's do the same thing for the oxide ion. So here is our oxygen ion. Let's go back and make it a neutral atom. So here's our neutral atom. How many protons does it have? It has 8 protons. So we're going to put that here. Now we notice the net charge is -2, which means that we should have a difference of 2 between our positive and our negative. And over here we can see that if we have a negative, that means we should have more negative particles than positive particles, right? And so our number of negative particles need to be greater than our number of positive particles. So we should have 10, because that is 2 more negative particles. And then finally, we're going to make our ion notation. We're going to put an oxygen, and then its net charge up at the top. And it's kind of weird. We actually put the negative sign second and our net charge 2 first. All right. I'm not going to really take off any points or point that out or make you correct it if you put the negative first. So that's all I've got for you right now. When you go through this document, pay attention to the patterns, and there are all leading questions up to number 16. Number 16 is a really important statement that you're trying to get to by looking at all the patterns, and I think that you can do it. You guys are smart. You can look through some old practice assignments, especially look at 2 ways to represent atoms. If you forgot what valence electrons are, you should go and take a look at that. Okay, and then these questions 17 through 19 are just looking at a couple more patterns that I think are important to ion formation. So have fun. Have a good day.